For thousands of generations, we looked up at the stars from the warmth of campfire light, bound to the cradle of Earth. We tracked the wandering planets and wondered if we would ever touch the deep dark of the night sky. Now we stand at the edge of the ultimate frontier. The next 100 years will redefine our species. From the lunar dust to the red plains of Mars and outward to the cold oceans of giant worlds, we are preparing to leave our home behind. This is the story of our migration into the cosmos, a journey spanning from 2025 to 2125. Our journey begins close to home. Between 2025 and 2035, humanity secures its footing on the Moon. The Artemis missions establish a sustainable path back to the lunar surface, transition from brief visits to a permanent presence. In high orbit, the Lunar Gateway station takes shape, a modular outpost of metal and solar panels serving as a staging ground for deep space. On the surface, habitats shielded by thick lunar regolith protect pioneers from radiation and extreme temperatures. Near the South Pole, robotic rovers and scientists harvest water ice from shadowed craters. This ice is vital, providing water, oxygen, and the fuel to propel us further into the dark. The Moon is no longer a destination. It is our stepping stone to the stars. With the Moon secured, our eyes turn to the rusty horizon of Mars. The transition into the mid-21st century marks the departure of the first crewed voyages to the Red Planet. This journey is not for the faint of heart. For months, astronauts endure the silent vacuum of deep space, protected from lethal cosmic radiation only by advanced electromagnetic shielding and specialized spacecraft hulls. Arriving at Mars presents its own trial, a harrowing descent through a thin, unforgiving atmosphere. Giant heat shields and retro rockets fire to slow the heavy descent vehicles. As the red dust settles, human boots touch Martian soil for the first time. The footprint left in the crimson dust is a testament to our resolve. We are no longer bound to a single world. Survival on Mars demands that we learn to live off the land. The initial footprints quickly give way to permanent foundations. Robotic builders mix Martian soil with liquid sulfur to print durable structures, shielding pioneers from extreme cold and radiation. Massive geodesic domes rise from the Crimson Plains, enclosing lush green hydroponic farms and bustling research sectors. Underground, automated systems harvest water ice trapped beneath the permafrost, providing life-sustaining water and breathable oxygen. These self-contained cities become independent ecosystems, recycling every drop of water and breath of air. Within these glowing bubbles of warmth and light, a new generation of humans is born. Children who will look up at a tiny blue star in the night sky and call the red planet home. As Martian colonies secure survival, our gaze shifts to the vast wealth drifting in the void. Between Mars and Jupiter lies the asteroid belt, a treasure trove of raw materials fueling human expansion. Robotic mining rigs latch on to metallic asteroids, extracting precious platinum and gold for industries back on Earth. Even more valuable is the water ice locked inside these rocks. Automated refineries harvest this ice, splitting it to create rocket propellant directly in deep space. The asteroid belt becomes the fueling station of the cosmos, liberating heavy spaceships from planetary gravity. Global coalitions and private ventures build industrial hubs on dwarf planets like Ceres, transforming silent rocks into busy centers of trade. The greatest gold rush in history has begun. With resources flowing from the asteroid belt, construction in Earth orbit reaches a titanic scale. Massive orbital megastructures begin to dwarf the early space stations of the past. High-strength carbon nanotube cables anchor the first space elevators, lifting cargo from Earth to orbit without the need for chemical rockets. Large rotating wheels spin in the silence of space, creating artificial gravity to keep thousands of permanent residents healthy during long-term stays. These colossal habitats function as spaceports, cities, and research centers all at once. Inside these structures, humans live and work in environments that mimic Earth, complete with parks, residential sectors, and industrial zones. Space is no longer a destination for a select few, but a permanent home for humanity. As our orbital ports hum with activity, humanity casts its gaze toward the outer solar system. Beyond the asteroid belt, the moons of Jupiter and Saturn become the new frontiers of scientific discovery. Icy worlds like Europa and Enceladus, once viewed as frozen wastes, now host robotic submersibles diving deep beneath their outer crusts to search for alien life in warm subterranean oceans. Meanwhile, heavy research ships land on the frigid surface of Titan, exploring its dense atmosphere and wide lakes of liquid methane. These missions require advanced shield systems to survive the immense radiation fields of the gas giants. With every probe sent into the dark, we edge closer to answering the ultimate question of whether life exists beyond Earth, transforming these distant moons into crucial staging grounds for our outer system expansion. Having crossed the vast ocean worlds of the outer planets, humanity begins the ultimate test of its engineering prowess: terraforming. We're no longer mere visitors in the dark. We are actively reshaping worlds. On Mars, giant orbital mirrors redirect sunlight to melt the polar ice caps, while automated factories release greenhouse gases to thicken the thin atmosphere. Simultaneously, we look toward Venus, deploying massive solar shields at the Lagrange points to block solar radiation and cool the scorching planet. Chemical scrubbers in the upper Venusian clouds begin the long process of removing carbon dioxide. These colossal planetary engineering projects are multi-generational promises, sowing the seeds of a future where humans can walk beneath blue alien skies without pressure suits. As planetary engineering projects reshape worlds, the demand for faster transit across the void becomes critical. Conventional chemical rockets are relics of a distant past. Now, massive starships powered by thermonuclear fusion engines burn continuously, cutting travel times to the outer planets from years to mere weeks. These vessels represent the pinnacle of modular metallic design, featuring glowing magnetic containment rings and sleek radiator panels that glow against the deep space black. Beyond fusion, experimental antimatter drives are leaving the drawing boards, promising velocities that are significant fractions of the speed of light. These engines harness the ultimate energy density, generating immense thrust through matter-antimatter annihilation. As these starships take shape in Earth and Martian orbital shipyards, the horizon of human exploration expands beyond the boundaries of our solar system, preparing us to leap across the interstellar gulf. 100 years ago, we stood on the shores of Earth, gazing at the stars with wonder. Today, our cities thrive on Mars, our ships mine the asteroid belt, and fusion engines carry us toward the edge of the solar system. Yet this is not the end of our journey, but merely the prologue. What civilizations will rise in the deep silence of interstellar space? What wonders await us around distant stars? The cosmic ocean beckons, and our journey has only just begun. Join us as we explore the future of humanity. Subscribe and follow our journey into the cosmos.